Good morning, everyone. We are from the Department of Computer Science and Engineering, Section B, third semester. Our subject is Computer Organization with paper code PCC CS302 for the session 2025-2026. We are group number 13 and today we will be presenting on roles of operating systems. Next slide. What is an operating system? An operating system (OS) is a specialized system software that serves as the intermediate between a computer's hardware and the end users or applications. It is responsible for managing and coordinating hardware resources such as the CPU, memory storage devices, and input-output peripherals, while also providing a stable and consistent environment for applications to run. The OS handles essential tasks like processing schedule, memory allocation, file management, device control, and security enforcement. In addition to resource management, it offers a set of system services with user interface, either command line based or graphical, that simplify interaction with the underlying hardware. Popular examples of OS include Microsoft Windows, Linux distribution, and Mac OS, each tailored to different user needs and computing environments. By abstracting hardware complexities and ensuring efficient resource utilization, the operating system forms the backbone of modern computing systems. Next slide. Types of operating system. Batch OS executes batches of jobs without user interaction. Multitasking OS. A multitasking operating system allows multiple tasks to run seemingly at the same time by rapidly switching the CPU between them. Networking OS provides services for computers connected via a network, example server and Unix. Distributed OS manages a group of independent computers and makes them appear as a single system. Mobile OS designed for smartphones and tablets. Real-time OS processes data immediately with strict time limits. Multiprogramming OS. A multiprogramming OS runs multiple programs in memory to keep the CPU busy. Next slide. Roles of operating system: process management, device management, memory management, security and protection, networking and communication, file system management, resource management, error detection and handling.
Process management. Process management is a core function of an operating system. It handles creating, scheduling, running, and ending processes while making sure resources are used efficiently. The OS keeps track of process states like new, ready, running, and waiting, and uses scheduling process methods like FCFS, SJF, and rounding robin. It also manages communication between processes, prevents conflicts using synchronization tools, and deals with deadlock to keep the system stable and fast. Next slide. Memory management. Memory management controls how RAM is allocated, used and freed so multiple processes can run smoothly without interfering with each other. The OS keeps track of each memory location, protects processes from accessing each other's data, and translates logical addresses into physical ones. It uses techniques like paging, segmentation, virtual memory, and solves problems like fragmentation to ensure memory is used efficiently. Next slide. File system management. File system management organizes and controls how files are stored, accessed, and protected on storage devices. The OS provides a logical view for users while handling the physical details. It manages directories, file metadata, and supports operations like create, read, write, and delete. It also enforces security, uses different files like FAT and NTFS, and manages space allocations to prevent fragmentation and keep data storage efficient and secure. Hmm.
In this slide, I would like to talk about the topic device management. The OS manages all input-output devices like keyboard, printer, and storage device rights. It uses device drivers so apps don't need to know hardware details. It allocates devices to processes, uses technique like spooling, buffering, and caching for speed, and makes sure multiple processors can share devices without conflict. It also handles uh, uh, device error and supporting plugs and play. Next slide. In this slide, I would like to talk about security and protection management. Security protects the system from external threats like malware or hackers using authentication, encryption, and firewalls. Protection ensures controlled access inside the system. So processes cannot interfere with each other. The OS uses permission access control list and isolation to keep resources safe. Logging, instruction, detection, and regular update keep the system reliable and secure. Next slide. In this slide, I would like to talk about the resource allocation management. The OS distributes CPU, memory, storage, and input-output device among processes fairly and efficiently. It uses scheduling and allocation policies to avoid conflicts and prevent starvation. Deadlock prevention and priority handling ensure smooth operation. The goal is fair, efficient, and conflict-free share of resources. This concludes my presentation on the topic roles of operating system.
The networking and communication management is the process of controlling and monitoring data transfer between devices to keep it fast and free from problem, ensuring smooth communication. Now, the file error detection and handling management is the process of finding mistakes in data transmission or processing and fixing them to ensure accurate and reliable communication. Now the conclusion part. Process management ensures smooth execution of process through scheduling, synchronize, and resource allocation. Memory management optimize RAM uses, prevent interference, and support technique like pegging and segmentation. Device management control and coordinate input output device using drives. Security and protection management give us the security and protect our data. A resource allocation management distribute CPU, memory, and device fairly while avoiding deadlock. Error detection handling are and the overall goal is to provide stability, efficiency, security, and a user-friendly interface for seamless interaction between user, software, and hardware. The bibliography. For making this PPT, we have to collect data from a website which is mentioned here. For example, like a Wikipedia is here and the IBM websites. And now here our presentation gets over. Thank you.